comparison of bullets and cartridge cases in the past and in the modern times. In the past, the bullet identification and cartridge identification was carried out mainly through comparison microscope or peripheral camera or by examining various marks. But in the recently developed methods, there is a great change. In 1992, FBI USA set up a new system called drug fire. This was meant to be a database for firing pin impressions as well as primer impressions, and a computer was set up which could be of great help to forensic ballistic examiners for studying firing pin impression as well as other impressions. When FBI developed drug fire, at the same time, alcohol, tobacco, firearm and explosive developed another system which is called IBIS, Integrated Ballistics Identification System, which also served as a great help in the identification systems of bullets and cartridges. In 1997, FBI USA and alcohol, tobacco, firearm and explosive, they developed a system called NIBIN, which stands for National Integrated Ballistics Information Networks. This was a better than earlier methods because the same computer could do the job which otherwise could not be done. This gave rise to the idea of ballistic fingerprinting, which means that any firearm developed anywhere in USA will be fired and its pin mark and database will be given to the computer, and that can be used by anybody automatically for speedy identification of firearms.
Dear students, after studying this module, you shall be able to know about the methods used for bullet identification, and you will learn about the phases and technologies used in world for weapon identification. Along with it, you will come to know about different systems operational in this field. Let us start with introduction. The minute it was noted that the bullet fired from a given weapon has a definite number of equidistant impressed grooves all moving in the same direction and forming same angle, and which was found same on every other bullet fired from the same weapon, the necessity of weapon identification system raised unquestionably. Likewise, it was not ever known that when the next logical step will be taken, that is, to compare the width number and degree of inclination of the grooves will show from a weapon to different make. That, however, required a significant leap in lateral thinking to show that all bullets, when fired by the same weapon, bore microscopic striae. Now, striae are the parallel impressed lines, also known as striation marks, which are unique to the weapon in which they were fired. Let us have a look on early cases of bullet identification. In June 1900, an article appeared in a medical journal by Dr. Hall that bullets, when fired through different make and type of weapon of the same caliber, were found to be impressed with rifling marks of varying nature. He, however, never expanded on his article any further. In 1907, US was capable to identify 33 weapons out of 39 used in firing in riots using magnified images of the firing pin impressions on the cartridge cases, using it as a method of comparison and identification. The work on use of photomicrographs, initiated in 1907 by Frankfurt Arsenal and was not renowned until 1912, being influenced by the publication of Sir Calvin Goddard. It was Victor Balthazar came to a deduction that the cutter that is used in rifling a barrel almost never leaves accurately the same making in its successive movements through a barrel. He reasoned that it is possible to detect beyond rational doubts that the fired bullet was shot from the barrel of a certain weapon and none other. This significance can't be overestimated, for it is upon this premise that the whole of modern science of bullet identification rests. Balthazar's work, however, extended beyond that of making striations on bullet and included the markings imprinted on fired cartridge case in self-loading pistol. The markings he identified has been those identifiable Stria which were marked on the breech face of cartridge by the extractor and ejector. Balthazar's work was, however, exceedingly labor intensive, requiring the production of numerous photographs under exactly the same lighting and magnification. This figure shows markings and matching spots of fired bullets and cartridge cases. In 1923, De Rechler and May published a paper discussing merit of using fired pin impressions, while other scientists wrote about minute irregularities in the breech face on the soft brass of American type primers. Now let us look on application of comparison microscope in bullet identification. To start with, Philip Gravel was the first to realize the use of comparison microscopy for forensic comparison of styria on bullets and cartridge cases. Spencer Lens Company manufactured the first commercial comparison microscope, followed by Bosch and Lomb and Leeds. For the first time, evidence based on comparison microscope was presented to the court of law on the United Kingdom in the infamous case of murder of Constable Guttridge. Brief facts of the case was that a fired revolver cartridge case was recovered from the motor car used by assassin of Guttridge. After several months of effort, the police were convinced that two men, Brown and Kennedy, were the culprits. Two revolvers were found in the possession of Brown, and the whole case got dangled on single question that whether one of these was the murder weapon. Eventually, by the help of comparison of striation marks, it was established that one of the revolvers did in fact fire the cartridge, and after a long trial, Brown and Kennedy were executed for their heinous crime. Let me tell you something about binocular comparison microscope. The next major improvement was the introduction of binocular eyepieces. It may, however, be noted that this does not give stereoscopic images, as each stage still only had a single objective lens. It barely made operational use of the instrument much more comfortable. It is often claimed that two-dimensional photographic reproduction of striations comparison do not represent the three-dimensional views obtained from the eyepieces in 2D, as the single objective lens used in comparison microscope is incapable of representing three-dimensional vision. Thus, there was some truth in the statement that a photographic representation striation matches were of little evidential use. After binocular comparison microscope comes photography of Stria. While most comparison microscopes have some form of photographic system for recording the striation marks, this is only of any real use in tool mark examination, since styria presence on flat surface may easily be photographed, but striation on bullets are on the circumferences of a curved surface, and only a small portion of this can be adequately represented in focus on a single photograph. However, modern instruments are now attached with a closed circuit television and a monitor connected to an additional video recording device. With this type of assembling, it is now possible to record the striation marks around the whole of the circumference of a bullet. Let me tell you something about NIBIN system, which is National Integrated Ballistic Information Network. NIBIN system may be termed as Fingerprint Bureau storing thumbprint of firearm. The identifying data from all licensed and factory-made firearms when generated for use are stored in the computers of the NIBIN. This data proves useful in the identification of firearms used in criminal activities. The fired ammunition available at the scene of crime can be useful in the identification of firearm from the recorded data saved on the NIBIN. NIBINs consist of the following four subsystems. Number 1, Data Acquisition System Remote. Number 2, Regional Server. Number 3, Match Points. Number 4, Rapid Brass Identification. It has its own advantages, that are: comparison is quick and takes much less time for completion. Number 2, comparison can be done at any point of matching where the facilities are available. Number 3, the deformed bullet can also be examined by the system. Then comes its disadvantages. The system is of no use if the weapons are not registered. Thus, country-made weapons enjoy freedom and criminals enjoys liberty. Another disadvantage is that if the firearm is altered, its characteristic will change and becomes unsuitable for comparison. Number 3, the identification may become difficult, if not impossible, in many cases where clarity of marks are not good. Fourth disadvantage is that many firearms used in crimes in our country are smuggled firearms or improvised firearms. Their records are not available anywhere. The fifth disadvantage is that if the firearm is not used repeatedly, no identification can be effected through NIBIN. There is, in fact, a long list of ballistics identification systems that are available in the market, and some of them are NIBIN in India, Arsenal in Russia, Condor by SBC Co Limited, Sibyl, a French system, Ballistica in Turkey, Fireball in Australia, Tyres in Russian system, and the last one is Evo Finder by ScanBI Technology. Now, India and NIBIN system. India is more or less a white elephant when its utility is considered in the light of current trends in abuse of firearms for crimes in India. NIBIN is indeed very useful in those territories where the same firearm is used many times at different places in the commission of crime. The author of Firearms in Criminal Investigation and Trial, Dr. B.R. Sharma, is of the opinion that not a single case has been solved so far by NIBIN, although it is in existence for more than half a decade in India. The reasons for this can be briefly mentioned as follows. It is not easy to get a valid license for a weapon. Hence, smuggled weapons commit most of the crimes. Their records cannot be obtained from any weapon dealer. Number 2. Standard firearms are quite costly and require a valid arms license. Terrorists resort to purchase of non-standard country-made cheap firearms whose availability can be easily made. Let us see integrated ballistic identification system. While FBI was developing drug fire system, the Bureau of Alcohol, Firearms and Explosives developed another system called IBIS, which is Integrated Ballistic Comparing Identification System. Before the integration of the system to be called as IBIS, it was only capable of comparing bullets and was called bulletproof. Later, it was upgraded to handle cartridge cases and then renamed as Integrated Bullet Identification System. As a result, from 1993 to 1998, the United States had two non capable automatic ballistic identification systems in place. One was drug fire and the other was IBIS. Although there were attempts to interconnect the two systems under the National Integrated Identification Network, it remained an unsuccessful exercise till 1999 when the FBI and ATF finally decided to phase out drug fire and to standardize NIBIN on the IBS platform when the evaluation revealed the superiority of IBIS over the other system. In 2005, FTI, which is Forensic Technology Inc., released its bullets, tracks, and in 2006 brass track systems, which enabled both 2D and 3D imaging of bullets and cartridge case Stria. This not only enabled users to take quantitative measurements of the surface topography of a bullet and cartridge case, but also considerably enhanced the capability of IBIS system. The adoption of IBIS as the NIBIN standard made FTI world's biggest manufacturer of automatic ballistic identification systems. The following important points are worth mentioning. Systems cannot at present replace the comparison microscopes. Both the system and comparison microscope are essentially required. A system may generate 10 to 20 top candidates as possible matches. The firearm examiner uses this list to select actual bullets or cartridge cases from outstanding crime index for visual examination and a comparison microscope. It is the examiner who makes the final decision as to whether there is a match, and it is he or she who testifies to this in court. Now let us see modern technology for Stria comparison. In 1989, terrible increase in drug related crimes in USA resulted in exceptional accumulation of fired ammunition submitted in the crime labs of forensic analysis. To avoid the difficulty, FBI selected only important cases of special attention. It was not possible to compare each bullet and cartridge case, which required plenty of manpower. However, to make things easier, large photographs of the bullets and cartridges cases related to the important cases were pinned onto the wall behind the comparison microscope. Rough estimations were used to determine whether there were any similarities between the exhibit on the comparison microscope and those on the wall. Understanding that this could be done carried out more effectively with the use of modern technology. The FBI sponsored research into digitalizing the photographs. Then the images were displayed on a high resolution computer screen in a tiled pattern surrounding the exhibit under examination. The system was called drug fire. In 1992, the FBI began the drug fire system. The drug fire system is a database of firing pin and primer impressions of spent cartridges recovered from the crime scenes. A computer network was set up so that firearms examiner could search the database for impressions. This enables the examiner to determine if a crime scene cartridge or one test fired from a seized weapon matched any of the impressions in the database. When a match is found, the arrangements can be made to procure the actual cartridge so that a physical microscopic comparison can be made. The method resulted in yielding more effective results quickly. Let us discuss about now ballistic fingerprinting. The development of bullets and cartridge database led to the concept of ballistic fingerprinting. Under this program, each new weapon is test fired at the factory and the cartridge is recovered. Breech block and firing pin impression are stored in a computer database. In cases where cartridges are recovered at a crime scene and recovery of fired weapon is absent, the breech block marking and firing pin impressions can be compared with those in the database. Though it sounds like that it will be a very effective program, there are quite a few problems, like it is very expensive to be implemented. It is quite often hard to substantiate a paper trail of a gun purchase. False identification documents may be used. Sales may be made illegally. The genuine owner may lose the weapon. Weapons may be stolen from the original owner. In case of firing of several rounds within a short time, firing pin impressions and breech block marking, like bullet styria, may change enough so that they can no longer be matched to a test fire cartridge. Now, let us summarize this chapter. In this chapter, I have told you that early efforts of bullet identification was initiated by Dr. Hall in June 1900. Along with it, you must have learned that in 1907 US was able to identify weapons by using ballistics identification system by traditional methods. And we have come to know that Victor Balthards in 1912 used photomicrograph technique for the first time to compare the striation marks. Along with him, Philip Gravel used the comparison microscope for the first time from forensic point of view. Because of the unfortunate availability and culture of country-made firearm or improvised firearm, it is difficult to examine fired cartridge cases in India. We have also learned in this chapter that the basic principle of comparing and identification of fired bullet is based on etching marks, firing pin marks, microstriations, etc. on fired cartridge cases.